Hi
Hey,
everybody. Welcome to the Wingley Show, the Wingley Update,
San
the
Zayal.
Wingley TBD. Is it already not TBD at this point? We're not. It's not a TBD.
We don't mention it.
We don't mention it. Eyal is not with us today because he's vacating with his family, and so it's me and Shai today. And so, hi Shai, what's up? How are
Hey,
you?
lad. I'm good. Happy that I'm not Ayal this time.
I see you have this lovely background.
Yeah, made with love by Amiel.
Amiel, who's Amiel?
Amiel. He's our designer. He's been working with us for a while now, just finishing his studies at Bezalel, and now he's joining us full time here in the team to lead all design related work. And he's like an amazing fit.
Yeah.
To
No,
the
now
team.
now we're gonna have like lots of like new stuff coming up all the time, which is really
Yeah,
fun. He
there's
also did the intro video, which
yeah
we all really like.
puts us in the right spirit for the beginning of the show. And yeah, so now there are no more excuses for not having awesome UI working with you.
So what's gonna happen today? What are we gonna do?
We're gonna start off with a chat with Adam Jacob, the creator of System Initiative and Chef, and it's gonna be a very interesting talk. We're gonna talk about his journey and about System Initiative and where uh, what we see similar and where our views differ. Then we're gonna have the Winglang changelog, third time. Seems like it's gonna stay with us. And we're gonna finish with Chris, talk about Wing modules and libraries, which is a huge building block for us. Um, we're super excited to have this.
Yeah, can't wait to like start publishing libraries.
Yeah.
Cool. So without further ado, let me bring in Adam. Hey, Adam.
Hello. Look at that. There was applause.
We actually have like some fake applause somewhere. No.
That's fancy.
Think that. Yeah, we have like a very high profile operation here.
Obviously.
We're just using like the screen in front of us to create proper lighting.
Yeah.
So that was like this today's new innovation in our studio.
It's a good move.
Thanks for coming, man. It's really,
Yeah,
really
my pleasure.
So I think what we like to do is kind of like start by getting some early as you want background, kind of like I'm always super curious to hear those stories and
Yeah.
journey.
Yeah, I mean, look, the short version is that when I was a kid, I liked bulletin boards, if you remember bulletin boards. And then like bulletin boards were the coolest thing about computers, which then sort of leads you directly to the internet, at least in America.
Did you have like were you owner of like a BBS?
Yeah. I ran my first bulletin board when I was like 8.
Really?
Yeah.
Oh my god, I love those. I was
love
totally
bulletin
into that.
boards.
I was totally into that.
Yeah, I'm a little upset that they're gone. Like every once in a while, I still like fire up something and go play Trade Wars, you know? And yeah, so I mean that led me. Sorry, what?
No, it's gonna be a new retro thing soon. Don't worry.
Yeah, I think it probably already is to
It
some
probably
degree.
always.
You know?
I'm sure there are.
Yeah.
Now you got me to like go search for something. Okay.
Yeah. So yeah, I like, but that led me to being a systems administrator and sort of the early eras of the internet, and then my career has sort of just followed the problems that have happened as we've grown bigger and bigger. Like initially the problem was how do you get people on the internet? Then the problem was what are they going to do when they're on the internet? And so we all started building applications so people could do stuff on the internet. And then we were like, hey, wouldn't it be great if what you did on the internet was hang out with other people? And so then it was like Facebook and like social media. And so at each of those stages, there's been some kind of, and then we were like, shouldn't all of the enterprises all over the world, shouldn't your bank work just like the internet works? And so like over and over and over again, we've just keep finding interesting new problems. And so, yeah, my career has mostly just paralleled those problems where it's been like, okay, whatever is interesting and is sort of next, then then you sort of tackle how to figure out how to make it work. And yeah, for me, that's mostly looked like operations and systems administration stuff. And it turns out what I like to do is I like to write software for those people because that's kind of who I am.
the,
The,
the inner BBS child.
yeah, the systems administrator, the operations person, the both with Chef and with System Initiative, it's like I write software for people who build infrastructure or who think about applications or, but I tend to be thinking about the technology that runs the technology as opposed to like, I don't build like StreamYard,
Yeah, I see. Total. Of course I know. And
yeah, because you are here and you build Wing and you know exactly what I'm talking about because you build tools for people who build tools, who use tools. Yeah.
Exactly. Yep. But I have to say it's pretty interesting because I also started programming in the kind of late 80s, 90s.
Yeah.
And I was always very attracted to like library and framework design and object-oriented programming, and kind of like basically constantly thought about the applications and how you're designing applications, which is really I've never ran a BBS board, right? Like I used to connect to some, but I've never. So it's interesting, very interesting.
Yeah, it just depends on like I think it's just it's the same part of your brain. It's just lit up in a slightly different way. Like one version of it, it's like, how are we connecting all the things together and figuring out how the pieces work more under the hood. And then the other one is like, how do I build something that people can use, and like, I was doing that too, but it was mostly like, generating characters for Dungeons and Dragons or whatever. But where I was spending most of my time was like actually figuring out like how it worked. Cause that's what I liked. I liked how the insides worked,
And you said that that you were drawn to the operational side, writing software for that. I think like early on, it wasn't so much software. I think you probably are one of the pioneers of writing software for operations.
Yeah, I mean, it was always software. We just didn't talk about it that way. So, like if you were around, if you've written like a SendMail configuration file, especially before M4, this is like your audience is like, what's he talking about? And it's like, this is the way that like email.
The entire conversation is basically not for our audience.
Yeah. Cheers. Yeah. I'm such a good guest. Like SendMail was like had a very incredibly complicated configuration syntax that allowed you to really tersely define how different mail transport formats interoperated. So you could like translate between email and like pack mail to talk to a bulletin board or to be thrown over UUCP. And like, it was great at that. It was incredible, but it was so hard to understand. And so if you were a person who mastered SendMail, like the book for SendMail was this big, like, and it was every ounce as complex as learning how to program in C. Like I still have a copy, like the KNRC book is right back there. It was like this big. And like which one is programming and which one's not, like I think when you think about it from the point of view of systems people, like that separation was actually sort of at the root of what brought us to DevOps, because we had sort of convinced each other that there was a delta there. And the truth was that there wasn't a delta there, that in fact, all of us were programmers the whole time. The only difference was what kind of language are we working in? What kind of problems are we trying to resolve? And how do we solve them? But we had created this artificial gap between systems administration and operations folks and software developers, which, to be frank, usually had software developers at the top of the pile and systems administrators at the bottom. And for me, that's one of the reasons I started building great tools for systems people, because I just, that was always bullshit. It remains bullshit today. If you're a great operations person, there are skills that you have and things that you can do that a fabulous software developer who doesn't know anything about how operational things work can't do. And in both cases, you're software developers. You're writing software. They're just different kinds of software for different purposes.
So interesting, because I think that this is why I built a CDK, right? And the CDK comes from that exact way of thinking is like, we're all developers, everything is software. There's no reason why infrastructure doesn't have to be, doesn't have to be treated the same as any other software piece that's part of the system.
Yeah.
And I still think so, right? Like I 100% agree with you that everything is software, but
yeah,
I do think there are different problem domains.
Totally.
I think different software engineers deal with, different software engineers in the different layers deal with a very different problem domain, right? Like the
Totally.
developers who build the applications, they're focused on the problem domain of the business, right? Like that's their world, and that's the mental model. That's the problem solving they're doing is at that level. And engineers that are working on the infrastructure side or on the operational side and the platform side are dealing with a different problem domain.
Yeah.
That's how I see it. So I think
and I think you're
about whether those are developers or not, or those are not, because I 100% agree.
Yeah, I think you're. I mean, you're manifestly correct, right? So like it's difficult.
That's how I like to be correct, basically.
Yeah, I mean, however, here's the rub, I think, which is that the focus. I think we got the focus a little off. So, if you looked at the first round of DevOps tools, we really embraced the idea that what we were all doing was automating the way that we worked. So we were looking at the way we worked. So we're looking at the way application developers worked. We're looking at the way operations people worked. We were putting those people together so they collaborated better, more. And we were trying to automate that process so that collaboration was made easier. And in the end, you'd be able to ship software faster, more stably, more reliably, more securely, right? I think what we learned is that the shape that we chose to automate was the wrong shape. Because it's not like any individual tool was a bad tool. They're not. They're all actually kind of great. But if you look at the results people are getting in the enterprise, like one of the reasons there's an opportunity for Wing or for a system initiative is that if you go talk to people about how they feel about the end results, they don't love it. They're like,
100% agree.
They're having a bad time, and
right. They feel something's wrong, but they don't really know what.
They can't really tell you what it is, right? And there's a really great Bill Hader video, which where he explains that when you're doing comedy, people can point out why something isn't funny or why it's not right, but they're usually right that there's something wrong in that zone, but they're wrong about the solution. All the time. And this is basically the same here too. It's like, yes, there's a problem. We know there's a problem. The question is what are we going to do about it? My supposition is that the problem is systemic, that the shape of the way we decided to work, what we wanted, the properties that we knew brought about good outcomes, started with collaboration. They started with how do we bring those application developers and those people who have operational expertise closer together so that the work they're doing feels more holistic and gets delivered together in one move. And then we made a bunch of software to try to do that by just automating the way that they worked nearby each other, and we were like, you can see it in the way we collaborate.
Can you give some examples?
Yeah. Like the normal point of collaboration in most people's DevOps workflow is the pull request review. And it's actually right there in the name. It's code review. It's not code collaboration. It's code review. Like somebody does it and then you tell me if it was good or bad, right? And I think when we think about the separation between application developers and operations folks, the truth is the end result is the same. Like if you remove the operations people from the equation, there's nothing for the application to run on. If you remove the application developers from it, then it doesn't do anything. And so there's no point in having infrastructure. It's just computers, which are, I guess, fun, but not particularly useful. And so
only the fun.
Yeah.
Companies that are selling their internal infrastructure to other companies.
Sure. Right. Yeah, exactly. All to do nothing. So I think so the example there that I give is that when you think about how we work, asking a developer to go read a bunch of Terraform to better understand what's about to change for their application as it deploys is not a good loop. It's not good for the application developer. They don't understand it. They don't understand how the infrastructure works. They don't understand the impacts of the plan. The feedback loop is really long. Maybe it might take you 30 minutes to know if you got it right or wrong because it has to churn through the actual AWS to do it. The plan tells you lies, all kinds of shenanigans you have to go through to sort of make that stuff work. And those foundational choices that we made early on that said, hey, the way we're going to represent this infrastructure is as code, or we're going to break the platform piece separate from the application deployment piece, or separate from the way that we do these other pieces. Those things are actually, I believe, what's actually causing the bad outcomes. It's not a technology question of like Terraform sucks, therefore the outcomes are bad, or, you know, whatever, Jenkins sucks, that's why your pipelines are not good. Like, it's not that. It's actually that the way we've assembled the whole shape of the workflow is wrong, and we need to change that workflow if we want better outcomes. And I think one of the things I like about Wing is that, you know, whether you phrase it that way or not, I think there's this recognition that there has to be a different user experience to solve this problem. That like changing the workflow of the user experience is the way that we're going to figure out what's better. And I think we're both making bets like that say, hey, let's fix this user experience, and that will go a long way in getting to better outcomes.
So how do you envision, just describe like what would be the user experience of someone, the team, you know, the workflow for teams using System Initiative? Like, how would that?
Yeah. So we think about it as essentially, we took a long time to build System Initiative. So it took us like 4 years. So we've built a lot of different things that we've been trying to figure out how to make it work. So we didn't just build one thing. It's not like we started with the right vision 4 years ago and then got there. It was a lot of wandering in the woods because our goal was to really change the outcomes. So where we landed was that in order to fix the biggest problem, which is feedback loops and inference. So the two biggest problems we think are how long it takes to understand if you've done something, if it's right or wrong. And then right or wrong is dependent on your environment. So like it's one thing to say that a configuration is wrong canonically. It won't work, right? It's another thing to say it's wrong at Citibank, or it's wrong at Ford, or it's wrong at Facebook, or it's wrong at Wing. And you need to be able to do both. And you need to be able to see that feedback in as close to real time as you possibly can. So how quickly can we know that that's right or wrong? So that led us to essentially building a simulator that allows you to model what's possible and then say what are the rules that need to be applied. And rather than actually doing it, if we make the model high fidelity enough, then that model can tell you in real time that you're right or wrong, and that it meets your policy or doesn't. And then the other piece is you need to be able to think about how configuration gets inferred. So if you think about how much we have to repeat a single piece of configuration across multiple layers of the stack. So a great example I use is, how do you know what port an application is running on? So you put the application in a container, you decide it's running on port 80. Now you want to deploy it to Kubernetes. So we need to thread that port number through from the Docker container to the Kubernetes deployment
to the values, to the Helm chart, to the
Helm chart, to the ALB that's in Azure, to the right. And the syntax there is also different. So the way you express it in Docker is like 80/TCP, but that's not how you express it in a Kubernetes manifest, right? You deploy that's got a totally different shape, which is different yet again from the shape that you express it somewhere else. So it's not only that value must flow, it's that value must be translated to semantically match across those layers to the places it needs to match. So we think about that simulation as essentially a gigantic graph that has multiple layers in time. And at each point in the graph, which is as low as like a single property, what you're doing is running a function that generates a value. And then you can essentially think about it as like sockets that will then flow that data through, where you can translate it, you can change it, you can infer values, right? The side effect is that you can really quickly compose those models together, and they'll keep their configuration correct, and then they'll generate the code from the model. So rather than starting as infrastructure as code, where you write code, the code defines what the world looks like and you do it. Instead, what you're doing is defining a model, and then the model derives what the right code would be. And for whatever the domain is, and then keeps it up to date because it understands what to do. And then the last bit is you have to track the real world state of the resources that get created. So if there's any, sometimes you're talking about concrete things like I want to manage an EC2 instance, or I want to manage a Lambda function or whatever. And sometimes it's abstract. This is my application, right? There's no such thing as the application. The application is like a conglomeration of all the stuff it needs in order to run.
Of course.
So how we think about it is you model all of those things in System Initiative. And then when it comes down to those concrete resources, we're also tracking those concrete resources over time and then letting you reconcile between them. So saying, hey, your model said that this resource was supposed to look this way, but it doesn't. And do you want to change it? Do you want to update that resource? Do you want to, and that maybe that operation is whatever it is, however the domain models it. Or it may be that the resource is actually correct. Somebody was troubleshooting, so they logged into the AWS console and they clicked a button that fixed a bug. So instead of having to destroy that or have your automation turned off, which people do all the time, right? Oh, we're firefighting. Turn off Terraform, figure it out, fix it, then go write it in the code, then redeploy it.
Move away.
Exactly. Here, we would essentially just let you change it however you wanted to. And then we would just look at the resource and notify you in the UI to say, hey, these two things aren't in sync. One thing you could do is change it so the resource is in sync with the model, or do you just want to update the model? And then problem solved. So, and yeah, that's System Initiative in kind of in a nutshell. And the core of it is that in order to fix what is wrong systemically, we needed to change the way we think about modeling the system altogether.
Yeah. So when you say who's the persona that you target to use System Initiative? Is it the DevOps engineer, the application engineer, both?
Yeah.
What's the flow like?
Yeah, I mean, it changes a little over time, right? So today, System Initiative is new and rough around the edges. And so who it's really ready for today are just innovative DevOps engineers who heard the description I just gave, and they were like, that sounds fucking cool.
Fell in love.
Yeah, and if you want to come hang out and it's open source, you can come hang out with us and build it. Let's go. So it's ready for those people now.
You guys just open source it, right?
Yeah, we open sourced it last week. All the software is open source. Every line of it's open source under the Apache license. Always will be. So that's what it's really. That's what it's ready for today.
Go ahead.
But eventually it'll grow. So because you have all this data in the model, and because it doesn't matter, you can model anything you want. It will eventually grow to do all kinds of stuff because there's all sorts of valuable information in there. What will change is the interface. So if you think about the jobs that we do and how we collaborate, there's not one universal interface that makes sense for every job that's involved in that full cycle of how we get an application out to production. So, the way that a DevOps engineer interacts, they're caring more probably about the infrastructure. Application developers care more about the application. They probably care more about things like deployment. They care more about test coverage. They care more about all kinds of other information. So over time, the interface grows and changes to sort of accommodate different personas.
This was extremely fascinating because I feel like we actually, in a sense, Wing is building this exact same architecture, right? It's basically you create a model of your cloud application, you'd model all those resources and all those nodes, and each node has relationships to other nodes, and some code that represents their behavior, and also a composition model where you can take multiple of those resources and create higher level abstractions from them.
Yep.
And then you synthesize configuration, right? Basically when you're compiling a Wing program, you're going all over this tree and you're synthesizing the configuration. It could be any
totally.
So I think there's lots of basically the same architecture for the systems, which is really interesting to me.
And I mean, it makes sense, right? Because if you sort of think about the history of our space, the there's only so many threads to pull on.
Correct.
And so it's the your recognition and my recognition of the same sort of feedback loop problem and the like abstraction and synthesis problems. Like those are the problems. And if you're committed to solving them, you know, like the
You end up
architecture,
with we end
with
up
a
with
simulator.
yeah, you end up with similarities, and what's like the differences are interesting and meaningful, but it's not surprising to me that there's more similarity there than there is difference, because if you're thinking about, you know, like Joe at Pulumi, for example, I think like had a very similar point of view about how Pulumi might have evolved in a different universe. Pulumi could have looked a lot like Wing, right?
Yeah.
And I think I'm not sure that the universe was ready for Pulumi to look like Wing, for example. So like
totally,
if you think,
totally. I mean, that's
like,
when I released the CDK, right? Like at that
yep.
exact same month, basically.
And so you wind up in this interesting spot where
evolution of designs, evolution of layers and abstractions, right? Like it's kind of like this organic process.
it evolves like art. It's always, we're in conversation with each other over a long period of time on the art of how this can work. Like it's art. Like I learn from you, you learn from me, we learn from Joe, we learn from Mark Burgess, from Luke Kinney. Like there's this huge long line of people, and you know, like you take those inputs, and what it comes out as is art.
Yeah.
You know, it's a good sign for both of us that architecturally it wound up being roughly similar, because what it means is we're probably right that art is somehow compelling.
More right. Yeah, a little more right.
We're more right than we were before we had this conversation.
Exactly.
Yeah, because and I think that really just points to this need for this like second wave of DevOps tooling. Like the thing I most want to see, like, of course I want System Initiative to like be the biggest business I can turn it out to be, and I want people to love the product, and I want all that stuff to happen. But like I also really just want to see all the different ways people will build new stuff when they realize that they can build new stuff again, and that changing some of those fundamental building blocks is actually quite achievable and can really be different in the way that like the outcomes can be really different than what we've had before. And you know, yes, it's riskier because you might be totally wrong. There might be things that you don't understand, like, but I don't know that we need another like a slightly better CDK. I just don't. But what would it do? Like, we've pushed on that angle for like a while, you know.
I agree.
And so we need people pushing on new angles if we want to see like really outsized changes.
And I feel like I want to say hallelujah.
Yeah.
No,
right.
I totally. It's also really, I love it. Right. Like I agree. It's kind of like this beautiful thing that happens. I actually had the same experience with Pulumi. When we released the CDK, the same month Pulumi released their beta, and I was like, "Oh my god, these guys are! What happened? Like, were they in the room?" It felt really odd, to be honest, right? Like, it was the first time I felt this kind of like you get to it's all about problem solving eventually. And I feel like we're trying to crack problems. This is what we do, right? And we're trying to kind of solve for many constraints that are like accumulating over time. And
you came from similar backgrounds. You were both
geeks in the 90s.
Well, but you and Joe, like I think in particular, have like a lot of background overlap, right? Like language design, like there's you're very have really similar backgrounds. But like,
I also feel like I learned a lot at Microsoft. You know, I spent some time at Microsoft, and I feel like there is something about Microsoft's proficiency in like designing developer tools and frameworks and libraries and API design and class library design. And I think that's totally correct, right? I feel like that's
I mean, as an outsider, I always felt like the people that I've known who were great at Microsoft, like part of what made them great was that they were very willing to like go to the fundamentals if they needed to. They
Yeah.
were very willing to be like, well, we could write a new programming language. Is that what we need to do? Like, do we need to write like whatever it is they needed to do? They were willing to go do it in a way that like other organizations often will hesitate. They'll be like, well, maybe that's too hard or it's too complex or we don't understand it. And like Microsoft does, I think, have a pretty solid history of finding a way to do that. And I think, you know, hopefully now as we sort of build this second wave of DevOps companies, like if we can figure out, you know, we have more in common. We're more alike than we are different. We have more in common than we don't. And I think what we need to figure out how to do is like, how do we stay in conversation with each other
Exactly.
so that those things do get pushed forward and those good ideas do come out and we can express them to the world in a way that's like, hey, we did actually learn that like that there is something really important about the idea that what we're doing is essentially building simulators that then like generate the configuration or generate the outputs or synthesize the results. Like it's just an interesting idea, and it's one who like it.
I think an area we can definitely talk about collaboration is specifications. You know, like open specifications for different layers, because I do think that there are, I do believe that different problem domains and different types of engineers, they like to use different tools, right? Like they have a different, their brains are wired differently. And I think like it's really interesting to see those two solutions kind of like coming from, two different paths to very similar results. But I do think that there is something about the interface, right? Like what interface you're using. And like you said, different people would want different interfaces. And I think it would be really interesting to try and collaborate.
Yeah, I think you have to think about, as we build and we do more, like, it took us a long time to build System Initiative. And I know it took you a long time to build Wing. And
not as long.
Yeah.
Yes.
But like, I think it's going to take the people who come after us less time. Like they'll have
also, and I think also acknowledging that there's an ecosystem, right? And every layer, there's always an ecosystem. And if the layer is well designed in terms of like collaboration around the industry, and it's usually about like specifications and standards, that's eventually the way you're able to create these like collaborative, just decentralized initiatives work together.
Yeah, for sure. I also think there's just a pure community building question, which is like one way that this goes as things happen over time is that, people love what they love. They love Wing, they love System Initiative, they love Pulumi, like whatever it is that you love. And the way that folks like us relate to each other informs the way our communities relate to each other as well, right? So, if we like each other and we like respect what we're doing for each other and we respect the way that each other are approaching the problem, then our communities become communities that respect each other and respect the way that they approach the problem, and like whatever they can talk about where they disagree or where they diverge in ways that are kind and sort of move the needle forward for everybody. And
hallelujah.
That's the way. So
absolutely.
So maybe let's kindly discuss a bit how where we diverge. So far, we've just talked about.
I think. Do we have time? I think we might need to like get Adam to. Would you be interested in? Yeah, I'm sure we'll keep in touch. And
yeah,
I think
we can talk about
time almost.
Yeah, I'd love to. Of course.
So we can discuss divergence in.
Oh, definitely, we should.
In a future episode.
Yeah, I mean, I think like we could absolutely talk about it because it's not like we haven't thought about it yet. So
yeah,
I'd be more than happy to talk about how we diverge.
That's what's gonna be really interesting to our viewers.
Yeah, for sure.
Cool. Any parting words?
No, I mean, thanks for having me. I appreciate it. Yeah, looking forward to it.
Thanks for coming, man.
My pleasure.
It's really a pleasure, and I'm a fan of the way you talk about our industry and what we're doing. And I wish I had more. I don't know. I wish I was better at that.
You seem
but,
pretty good at it so far.
I'm not really, but I knew it's going to be a really fun conversation. I love all the anyway the shared value system. I think like that's
For sure.
really fun to see, and looking forward for like collaborating.
Definitely. See you later. Thanks.
Hey, see you later, man. Bye bye.
Bye.
Okay, that was super interesting. I think it's exciting in many ways. Anyway, okay, so we have some music coming up, and then Mark is gonna give us his changelog segment.
Woo-hoo.
Bye, Shai.
Knocked his ass out and kissed him on the cheek, He fucked up just by thinking I was sweet, I run the city mag, I thought I was some cleats, You ain't never heard someone like this upon the beat, Tutti fruity, the booty duty is jury duty. Moody foodies, jacuzzis is filled with bougie booties. All of this money don't know how to count it, man. I think I need a computer. I can't live in deep, man. I live at the funeral. I got.
Shai, we can see you. Wait, don't we have like the thing for the changelog? Come on, Mark, go away. And also, I also said goodbye to Shai. Mark doesn't like threesomes. He just likes like two people.
No, I know, but I thought like Dana, don't you have the control?
Dana's not in control. Okay, so Shai, see you later. Wait,
So
see,
I'm gonna log off.
and
bye-bye.
we'll get Mark to
It was a pleasure. Hi, Mark. Bye, Mark. Bye, Anna.
go for it, Dana.
Hello, world.
Hello. Okay.
That was something.
That was a shit show.
That was a mess. I loved it though. I prefer a mess. I don't think a well-run show
Sorry,
is for anyone. I don't think anyone wants to see like a well-oiled machine. It's not really that. I would read a book if I wanted to do that. I would go like. That's not. I'm not here for.
That's not the format.
No, I want goofs. I want gaffs. I want laughs.
Exactly. No, I think it's Eyal is not here, so we're struggling, but we're doing our best basically. So what's up, Mark?
I'm hanging out. It's what is it? It's 2:30. It's 2:38 p.m. here, and I've had coffee and I ate cake today.
Okay.
I feel like shit right now. That's what I'm doing. But
And
I'm still
after
excited
that-
to do.
After that, you're gonna have some lunch.
Maybe more cake. I'm just kidding. I'll try to. I made ropa vieja yesterday, which I don't know if you had that, but it's very good.
What's that?
It's like I think it's a Cuban dish. It's like a stewed meat with like tomatoey and spices. And yet I ate cake today. That's what I ate. I have that. I have that ready, and I ate cake instead. So that's what I'm doing.
Okay. So you want to walk us through the last 2 weeks of new stuff and drama happening in the Winglang world?
I can do the first part.
Okay, no drama.
I don't know which drama. Is there
We're
a drama?
we're not relicensing Winglang as no.
Oh, okay. Yeah, well, we won't talk about that now.
Okay. So
yeah, I have it shared. It's ready to download. There we go. There it is. So even though I feel crappy, I'm ready to do this. I'm excited. Same format as last time because why not? I already did all that work. I'm going to reuse it. I'm not sure what I'll do it again though. I might try something else fun next time. Unless I don't feel like it.
You should.
In which case I won't.
Have you published it? It should be like open somewhere.
I should. I have not. But I will. Donna's already asked me to do it. And it's a good idea, especially with this. You can even publish it as a site too. Like it can be even in the Dobson blog or something.
I love it.
But yeah, here's the next entry since the last Wingly. except for the first one, which I actually want to call out a change from Marcha that was in. It was technically in last time, but I just didn't see it. I mean, I knew it was changed. I didn't mention it. But I definitely want to call it out that we now have variadic arguments of both like the support for declaring it and consuming it within the language, and that was a really, really super important feature.
And also importing JSI libraries that use variadic.
Oh, you caught me.
Oh.
Yeah. The reason I remembered it is because I was like, oh yeah, Chris added this, but wait a minute, I never mentioned that we added support for it in the base language itself. So yeah, now it's also consumable from JSI libraries, which I feel like this might have been the last thing that made, like, JSI libraries were pretty widely usable, but I think this might have been the last thing that was like a blocker for some people in terms of some aspects of it. I may be wrong, but I think that might be it.
Yeah, I can't think of other missing. So basically, now we support full support for JSI libraries, unless discovered otherwise.
Unless we don't, we do. Unless we don't, please file an issue. Contributions welcome. So yeah, we got those in. Super big deal. For some other changes, Mutare had some additional APIs added. One from Ananthu is set. So being able to, I had to go to this, to, like, if you have an array and you want to change one of the values, you can take the index and the value and change what value that is.
I love the meaningful example.
Right? Isn't that great?
And also, I love that you're using, deep equals.
Yeah, I think that was mentioned in the last. I
know, but it's like, I really love this feature. I don't know why. There's something about me that kind of like always resented the fact that equals doesn't work like you would expect it to work, right? Like it's like.
Yeah, I get what you mean. It's like, oh, it just doesn't. Yeah, I feel you. So it is nice. It's nice that I was able to. I wrote this, and I'm like, that's how it works. Like, it kind of, they're equal, right? So they're equal. They look the same. I mean, of course, there's more nuance to it, but like, they're equal, right? They're equal. Here you go.
Yeah.
So.
Hey, Weeping Clown 13.
Oh yeah, that's. I should ask people what name they want to put on here, because Weeping Clown 13 is Ananthu.
Oh, hey Ananthu. Okay,
I believe it's him. Anyway, but the next one.
Well, now we blew his cover, basically.
Yeah, I also should have asked if he wants me to blow his cover. Whoops. Next up was a change from Gary, who does not have an image on Slack or GitHub. So I gave him one. You can let me know if that's an issue. And he added insert, which similar example. Just we want to insert in the tooth position. Which is better than the second because it's 0, 1 tooth.
Right.
So
it's zero base. You can't use the second with 0 base.
Exactly. So it's the tooth. These are the kind of APIs where it's like, oh yeah, you need to be able to do that for mutable arrays. It's kind of like a.
Can you add like multiple items?
I don't believe this is variadic, but we have variadic argument support, so it could be.
How did you say that? Open issue Filebug contributions are welcome.
Created issue contributions welcome. The slogan of a open source maintainer.
Yeah, exactly.
Okay, big one, super big stuff. So JSON, as people may or may not know, JSON objects in Wing are kind of like they're not statically typed, but the only constraint on them is that they're a JSON compatible data structure. So it could be anything from a number to a dense object. And we had no way of, without you writing yourself, like something to convert from a dynamic JSON to a struct where the type is known, even though it should be possible. So Hassan added the from JSON method, static method to structs that will take JSON and convert it with proper checking into the struct at runtime. This includes, errors as well in the case where it's like age should be a number, and if it's given as a string, you get validation at runtime. It doesn't just explode; it gives you a proper error, like you might get from a validation library.
Basically, a JSON schema checking error.
Exactly. So this is pretty huge. I wanted to fit better examples, but I wanted to also be short. But I mean, this is like crazy common to get data from an API, and you're like, I'm pretty sure I know what the type is, but I don't want to just be stupid and assume it's a certain thing, and I want the validation layer in there. So extremely common use case that's super important to have.
Yeah.
No
Definitely.
words for it other than this is important. I think.
Yeah,
It's like
no,
a pretty
I think
huge...
not that I think I'm really excited about this. I think like that's it's kind of like we've talked about it originally, but this is now we're actually have that implemented. It's kind of like an area in Wing that's like cloud oriented in a way, but not in the in-flight sense, right? Like it's basically this is stuff that we constantly do in the cloud, and we want to be able to have the language, intimately familiar with this with this process. So I'm super excited, and as I said, there's basically a JSON schema behind it, and so there's going to be, I don't know that that's implemented already, but there's going to be person.schema, which will basically return a JSON schema.
Yeah, I don't know if it's implemented either, but I mean the architecture's there for it for sure.
Yeah.
But yeah.
And then you can like use it to generate API specifications, and like, so think about generating API specifications using Wing struct. So basically just specify the struct, and so I'm super excited by this.
Yeah, for sure. Same for me. The next one looks related, but is not. So a change, I made this change, but I didn't want to put my picture on there because it's weird to do that.
I mean,
but I did do this.
It's already on screen.
That's true. Yeah, exactly. In the corner. So the big change here was, and here's an example of like a situation you might run to that you hate yourself because you're trying to write all this code, and then partially this looks bad because we don't have like type aliasing or anything, so you have to keep writing out that. But even if we did, there's still types. Oh wow, this is great that this pops up every time. So that's still there. So why can't my compiler do that? Why can't my compiler do that for me?
Oh, nice.
Do the proper flip. There you go.
Nice.
So now the compiler can. I'm gonna use the word infer, but the compiler can figure out like, okay, this, even though this looks like a JSON object, it's actually a struct. It's being used as one, and we can know that the types in it are correct. That's why I kind of said implicit struct construction or JSON casting. This technically works even if your JSON is declared outside of this block. But I think this is the primary use case that we care about for that you would actually very commonly run into in many JSI libraries with any sort of nesting. And
I think the fact that it works outside of this block makes it, like, I remember when you talked about implementing it, I didn't realize that this is the use case that you were thinking about, right? Like if I have a JSON thing and then I just put it inside. Is that, there's an example? No, like
no, I don't have an example.
Yeah. So the fact that it's actually doing static structural type comparison, right, between the two.
Yeah, I found it to be a robust solution, even though this is the actual problem I was trying to solve. Like this was the whole goal. But
yeah,
turns out
initially I was like, I wasn't sure that would be my. Yeah, I mean, I wasn't sure if that's the right solution, but I feel like that we will really like this capability eventually.
Yeah, to me, there is something to be said about like the place that JSON and struct and like objects have in Wing. Like maybe there's even some more mushing together. There was talk in the implementation of this. I think Chris brought it up that like a JSON literal and a struct literal are like the same. Like and a map. I mean, the syntax is different, but like they're all objects. So it's there's some maybe I don't know. There's something there.
Tighter relationships, basically.
Yeah, exactly. So that's not change.
You know where I use it the most for returning a result from an API callback.
Exactly, it works there as well. I was going to put that example here, but I'd like the effect of all the text disappearing.
No, this
Kubernetes
is
stuff. But yes, it works also for returns, even so it doesn't have to be within like a nesting. It can be anywhere where you're taking a JSON and trying to use it like a struct, basically. So next up, I wanted to call out first contribution from Akil to add an API to Bucket called add file, which I think it was like one of the, and I can remember from when I use CDK, that was like probably the main way I interacted with it from what I didn't know was called pre-flight back then.
Nobody knew.
It was pre-flight, but I didn't know that existed because it didn't. But it's one of the more common use cases, and now we have it as available as an API bucket as
Beautiful.
well.
And there's this interesting thing here. I think, correct me if I'm wrong, that the path to the file is relative to the Wing file.
I actually don't know. I know there's ongoing discussion about this, I believe.
Yeah. There's this thing in Wing that I want us to support, which is that APIs can basically add an option that Wing injects transparently into the API that gives the API context about the source file, right? Like who called it.
Mm-hmm.
And so you can implement something like that, right? And so now we have like a baby version of that. I don't know if you're familiar with this environment variable of like the entry point directory that
I believe I added that, and I actually but it's caused problems. It's caused quite a few problems, and I know
because we've never really finished the project. I feel like we need to like add more built-in support for something like that, and then it's going to be really powerful.
Yeah, especially now with it was okay when there weren't multiple entry points.
Correct.
It was added for extern, and now it's no bueno.
Oh, it was added for extern. I thought it was added for a website. Okay, cool.
Yeah, no,
it's also used by the website API.
Yep.
Anyway, we'll solve it.
We'll figure it out. It'll be fine.
It's actually something that's really missing in in JavaScript, for example. You can't design APIs like that. You can't design APIs that take relative paths to the consumer, right? The code that consumes the API.
Not reliably, yeah. I mean, it's JavaScript, so you can kind of do whatever.
Stack trace. You can look at this. Yeah,
exactly. Okay, so last on the list, I always seem to end with VS Code VS Code console stuff, and I always struggle because I'm like, it's like perfect already? Like everything's so beautiful and amazing, and it keeps getting better every time. And I'm gonna say it every time, I think. But anyway, the feature added by Pol was so I think last time I talked about that now the console's pretty tightly integrated. It's into VS Code rather than kind of just being like a separate thing. It's in there. And an additional enhancement to that is now whenever you choose a theme, the color scheme within the console matches that scheme, not just light mode, dark mode.
Nope.
Which is good. That was good enough.
Right. I was like,
that's what I was like. That's fine. Now it was like, oh shit. Now it's literally the entire like palette matches.
It's amazing. It's amazing.
That's nuts.
It looks.
Bring your own theme to the console.
It is amazing. I have to say, it's like top notch.
And there's a PR open for another console change, and like I can't wait to say the exact same thing about that change in 2 weeks. It keeps going.
No hints.
No, because I forgot, but I was amazed when I saw it.
Like, remove dot from title.
It's yeah, it's something that crazy.
Yeah, this is good.
And that's the changelog.
That's a wrap.
That's a wrap.
Do the theme again. I love the theme. Yeah, the changelog theme.
I can't.
There we go. Hi, Chris. Hey.
Hi, Chris, sitting down.
Hey,
You see?
how's it going?
Now we have Chris.
Should I
What did
go?
you think about the new changelog theme?
It's fantastic. Oh my gosh. It's catchy.
On point. On point. Oh, now I remember. We wanted to do more music before Chris. Okay, we can still do. We can. So Mark, thank you so much. It was amazing to have you again, and looking forward for the next changelog. I'm curious. This is great. I love this. I love this corner. Bye.
Thanks. See you guys.
So, how are you, man?
Good. And the conversation with Adam was so interesting. And
What did you? Any thoughts? Any kind of?
I mean, one of the ideas that just kind of resonated was this whole idea that, like, you know, or it reminded me that, like, at the core of like a lot of interesting problems in software engineering are just graphs, right? And I feel like that was an interesting, like, common thread, like in System Initiative, you know, they're modeling things as a graph of objects in your application tree. I mean, even things like PageRank, you know, which made up Google, that's just graphs, really. And in Wing, we're building this language that, you know, we're using the power of compilers to understand your application better as a graph and give you better logging, insights, you know, operational tools and so on. So it's super interesting.
Yeah, I really enjoyed it too, and I'm excited to see where it goes and how it evolves. And I love the fact that, you know, the open source the project. I feel like that's and we'll see. So it's been a while since you were at the show. Thanks for coming back. It's really great to have you.
It's my pleasure. Yeah.
I'm sorry Ayala is not here. It's always more fun with him, I feel, but we need to give him a break sometimes. And so I thought it might be interesting to, like, talk a little bit about the work that you've been doing around modules and libraries. It's like a big theme, obviously, for any programming language. And I don't know if people notice, but so far we actually, like, just supported one file, which is, you know, surprisingly took us pretty far to an extent. I think it was an interesting decision. What did you?
Yeah, you can go very far with just single file programs.
Yeah, apparently. Well, not very far. We actually, I think, didn't build huge things with it yet, but it was definitely missing. And so the first thing that you added was support for multiple files. Can you tell us a little bit about what that looks like, what that means? If you want to show us something, that would be also possible.
Sure. Yeah. I mean, like, at the core of it, like, yeah, let's see if I can share my screen. Yeah, basically we can write programs in Wing that span, you know, multiple files. So, and the main things we can share across these different files are, you know, things like classes, structs, you know, types and other
declarations.
Data types. Exactly, declarations. So here's like my main, like, let's say I create a module, you know, the silly dumb example I always use is just like, you know, you have some kind of store, or maybe you even have like, maybe we'll call it a cache this time, just to make it, and you can, you know, have some kind of basic functionality. So let's say bring cloud, gonna have to define things. By default, right now, we haven't implemented like public or private specifiers. So everything is just kind of like magically exported or public today.
Everything's public. Everything's public.
Everything's public. But
because we couldn't start with everything as private.
Exactly. Yeah, we have to start from somewhere.
Exactly.
So, and then importing it is kind of with this basic, it's with the Bring syntax you might be familiar with, but you just specify the relative file name. And of course you give it some kind of name, and then, yeah, you can, what was it? Store dot cache. Yeah. No, some of the LSP things, like we're getting, it's like 99% working, but there's always a few gaps.
There's still no doc completion for modules.
Yeah, but it does compile, so that's all great. Yeah,
Okay.
I don't know. There's some interesting things about entry point files and non-entry point files. But
what about that? Tell us, because that was exactly what I wanted to ask, right? Like you talked about declarations, but there's also statements, because in Wing you can actually just like write some code that just runs in pre-flight. And so how does that work with modules?
Yeah, it's a great question. So I think it comes down to understanding like what makes classes in Wing special, right? Wing pre-flight classes, or there's kind of like these two flavors of classes. We, unlike just a regular class in Java or Python, we're actually building this like in-memory tree that represents the graph of your application. And we do this, for a number of reasons. One is just to kind of give these stable names for cloud resources. That'll be like stable names across compilations. But a consequence of this is that, you can create all of these, instances of classes, from different libraries. We create a cloud queue. And these basically end up forming a tree of resources. So all three of these classes are implicitly, right, injected. They're basically implicitly children of the root of the application. And then these themselves might have their own resources, right? So each cache has its own bucket. So I don't have a great way to draw it, but you can imagine there's like a root.
I mean, you could use the console.
Exactly. That's actually a great point. Okay, so yeah, we have to give each thing a name. Let's do that.
I don't know how to visualize this idea.
If only there was a way. Oh my god.
If only there was a way to like represent the tree.
And so here we have it.
We actually have the tree, right? Also on the pane on the left-hand side.
Yeah. How does? I don't know if I've actually
just
used
open
it,
it and you'll see it. It's kind of weird.
Okay. Here we go. Right. So here's the tree of resources. So inside of the first cache, there's a bucket. Inside of the second cache, there's another bucket, and so on.
But your point was that there's a single root, basically, right?
Yeah, there's a single root. And so there's this question of like, once you have files with multiple projects with multiple files, like, are they all just kind of implicitly adding things to the root? I think the issue is that it kind of gets messy, right?
I think it's not just about getting messy. I also think it's like, a bit more philosophical, right? When you're creating a module, there is a concept of entry points in programs, right?
Right.
C has a main function. Java has a main function, right? Like Rust has also main. How is it called in Rust?
Yeah, it's also main. Yeah.
Also main. And so this idea of an entry point exists in all programming languages. In most of them, it's not part of the language or part of the syntax in a sense. It's kind of like a convention that tells the compiler what is the main entry point, what is the entry point of the program, and that's exactly the same thing with Wing, right? Like I feel like there's an entry point, there's a root, and from that root there's a tree, and there's a single root, and there can't be multiple roots, right? Like that's
Right. Yeah. Like if you have a Python program with two main, yeah, it doesn't make sense. You usually the language requires just one main function. So
Exactly. So in Wing, it's basically this entry point file.
yeah. So the entire file is just we treat it as an entry point file, and then everything that's not an entry point file, you can just only define. You can declare things, but you can't, instantiate them at the global scope, right? And that's the main difference.
Yeah, and there are also no like unexpected side effects. I think JavaScript has this problem where you can actually write code at the root of every file, and then you require that file, and code is executed as you import the file right into your code, and that could create side effects. And those side effects could be hazardous in cloud systems, right? Like you could potentially imagine a situation where a library or a module would create a resource that would cost you $1 million a month, and you wouldn't even notice, right? Or
yeah, unless you have the Wing console, but
unless you have the Wing console.
but yeah, no, it's side effects. It's just also just like hard to like it creates more things you have to kind of track in your mind. Like, oh, if I import this thing before that thing, then it changes what happens. Like, we don't like that.
Yeah, and we do have some. You added some protection against cyclic dependencies, which I think is another.
Yep. There's all kinds of issues with like. I mean, yeah, it's graphs.
It's all graphs. Cool. This is exciting. I mean, again, I think that it's definitely something that is table stakes. We can't call this a useful programming language without supporting something like that. I think the next step is libraries, right?
Exactly. Yeah. So when you think of modules, like, I mean, we have these multiple file projects. What does a module do for you? I mean, one thing is you're using it to just kind of organize your code, like group together different resources. A really important thing is like when you have really big code bases, maybe you want to have a class with the same name, in a different folder, because you don't want to have to deal with all these naming collisions. Modules help you with that. So in some sense, they're kind of a unit of composition. The other part is that modules let you package your code and share it with others, right? And the basic interface in Wing is that a module represents, a collection of classes, structs, enums, and interfaces, right? So that's what we're working on.
You meant a library, right?
A library, right? Yeah, package, library. I mean,
yeah. So we have modules, which are kind of like a local file that you bring, and the library is a way to package a module basically and distribute it, right? So it's kind of like it's still
exactly.
a module.
Yeah, cool. And it's something we're working on. Like, I think.
What about like versioning, like package managers, stuff like that?
Right. So once we start, sharing these modules, these libraries, there's a lot of complexity, and this is what software engineering has become, right? Like it's managing all these dependencies. How can we make it easier, smoother? I think for Wing, we're thinking about this both from the ground up and also just pragmatically. Initially, we're thinking of starting right with basically packaging your library as an NPM module. So kind of like how CDK libraries were all NPM modules, it'll be the same thing. But yeah, that will kind of let you resolve dependencies using existing like semantic versioning and other mechanisms like that. So you
basically using
make a breaking change.
Sorry.
Yeah.
So basically,
if you make a breaking change, you'll do a major version bump and so on. Yeah.
Okay. But yeah, so basically using npm as the package manager, like that's the original that's the initial thinking. And so package JSON files and npm install and everything else, right?
Yeah, I've actually already started like kind of incubating this a little bit. Like, let's see
Okay,
if
now
we can
I'm
package
curious.
this. Actually, let's just try. Okay, let's actually see if this works. Let me. I haven't tried multi-file projects.
Oh,
No, it should work though, maybe.
Go ahead.
So if I write, oh, I called it
Pack.
pack just to be. All right, we want
Got
to.
it. Nice.
Here it's like asking you to just create a package JSON. Because we're kind of building off of that, it kind of makes sense. If you're using any dependencies, you already need a package JSON today. So
right. Any like
we might change that.
CDK dependencies.
Right. And then once you've done that, right, we have this kind of convention where maybe there's like an entry point for your library. Because we need to know like here there's two files, main and store. Like what are we actually packaging up? Like what's the first thing that people import? So
although interesting. So will it just have internal brings basically? Because it's an interesting thing. Because
there's some design work needed.
If it's a collection, then it's a collection, right? Like it doesn't matter. There's no tree, right? In this use case.
Right. Yeah, we could like also say
like star dot w, right? Like just give me like a bunch of W files and it'll bring all their dependencies as well. But you can have multiple entry points theoretically.
Yeah, theoretically, yeah. I think definitely doable. Although sometimes it's good to like have some way to say like, okay, I just have a bunch of module files. These are private. These are public. We need some kind of mechanism for that. But yeah, we'll figure out the right thing. In either case, here we can just kind of like rename it, I guess. We'll name it lib, and then let's try packing it, and we get a tarball. So,
yeah. And what's inside the tarball?
Oh, he had to ask. No. No, it's just the things you expect. Like, okay, so we don't want to package target, so I need to work on that. But it's the Wing files as well as any JavaScript you're relying on.
Show me. I can't see it actually.
Oh, I'm sorry.
I think it's just next to. Yeah, there you go.
Yeah, I would like open my Finder.
Okay, so there's like an index file that has what?
So this is just like I think a convention of like npm libraries. Like you need.
You need an index file.
You need like a main to point to something.
I think I got it. I think maybe we can like emit an error or a console log or something, right? Like some side effect maybe.
Gosh, that's controversial, man. No, I agree. And yeah,
okay.
then
basically
the
the two W files.
Yep.
Nice. Okay. Can you consume it already?
Not yet. Work in progress.
But wow, I'm so excited by this. Okay, I'm getting a signal that we're like way late, which is to be expected given AI is not here. Chris, always a pleasure. Please come more. And can't wait to play with the libraries and modules and start publishing. I'm constantly having some ideas, and I was like, I wish I could just like publish more libraries. It's like litter the world with like.
I saw how many libraries you published on the CDK team. I know this.
Exactly. So I really wanted that. It's also a way for me not to like to not get in the way and like just like kind of publish stuff that's. I feel like it's very exciting too. Cool. So thanks so much. Have Dana, are we doing like the? Okay. Bye.
Bye, everyone.
Shooters. I'm getting bigger. Do you wanna lost control